I'm Norbert Vaassen, energy engineer, and today I will talk about experiments with the burner. In the first video, video number 5, you will see it on the channel, I talked about barbecue, which I retrofitted to become a waste oil burner, but also with a thermal storage, which is unique on YouTube because I didn't see it. And I thank you also for the comments. In the comments you shared what you would like to see. And now I started in the last weeks with the experiments. I will show you on the video what I did, and I made this retrofit, and it was not only about the burner, it was also of course about the auxiliary systems, and those are the supply of fuel and also of the air. Let's now take this object. So now you see here this barbecue, which I found on the market, which had already a fan with a speed control. I changed the burner from charcoal to waste oil, and I made this fan much stronger because to burn waste oil you need a lot of air. So I had to retrofit everything, also the speed regulator behind this knob. You will see also burning experiments. It was not a complete success because the flame was unstable. So sometimes it would burn a little bit, but then it would be blown out. So it was not stable, and at some point it would the fire would get bigger, and then it would grow very fast, and then it would really be a blazing fire, and it would come out everywhere. I put a gaze on it, so like a meshwork of stainless steel on top of the burner. So here you have the burner. I showed it last week. You don't see anymore the reading on it that it was fish. But anyway, in the last video you see that it is made of two tins which fit one into the other, and that the air is going here inside and it's coming outside in these holes, and these holes will blow into the fire. So then this fire would be fed by the normal air, so 21% of oxygen. And then I saw on one YouTube that if you put mesh on it, and here's the mesh, it's completely dirty, then it will start to glow because of the fire, and this glowing, it will clean the combustion gases. Because if you have soot, these small particles of carbon, it will touch this glowing meshwork, and then it will start to burn. So that means it will give also a counter pressure. The flame will tend to remain in this area. And indeed it worked, it was an improvement. But anyway, the fact that it was unstable, that stays. So that is something that I have to improve. And I see so many YouTube videos with a burner, with a nice blue flame, and I could not obtain this blue flame. So I think imitate those videos where I see this blue flame. And at least then, if I have that, then I have a reference result where I can integrate also this thermal energy storage, which I have. And you know, the thermal energy storage, I think it's a good idea. First because it will allow you to burn outside and then have a lot of heat which you can take inside your house, and then you have no emissions at all. And that's one thing for space heating applications. And from the other side, the thermal energy storage is also something which you can use for cooking, so that you have a thermal energy storage which is heating here on top of the burner, and then you can bring it in house, and then you have something completely emission free, which is safe to use in the house, safe at least from the point of view of the fumes. And it will also allow you to have, for example, 15 minutes of cooking, because I made the calculation that with 5 kilograms of energy storage, a plate of 5 kilograms made with pebbles or stones or whatever, you will have at least 15 or 20 minutes of cooking time, during which the material is more than 100 degrees. So that's for the burner. And now about the fuel system. Of course you need in some way a fuel oil which is coming into the burner. So it, in some way you have just to bring a pipe of steel, of course, not of plastic. It will drip oil with the right speed into the burner. So I made there a kind of a flable, like in the hospital. So we have a bottle, it's suspended, and from the bottle comes a hose, a small hose, that goes into a regulator. And from there it goes into kind of a looking glass. And there I made also some air, so you don't see it, you don't see this line of oil, you don't see the tips, it just goes, sticks to the walls of this looking chamber, and you cannot see anything of it. So I have to redo that, and I have also to improve this regulation system, because you see here this kind of tap. It has the tendency to be open or closed, because even if you open it a little bit, then the oil will just flow very quickly through it. So I think I will do it like in a hospital, that you have just a kind of a pinch around the hose. You will screw it and it will easy to fine tune it. And then I will make the looking glass, that you have some place where it comes just out and it goes into an open air, and you look into a hole and you see just dripping, and then it goes into a funnel. So then I have this oxygen generator, and indeed I tried with different concentration levels of the oxygen. If you have very concentrated, 90% or higher, then you will have only 2 liters. So that means that if you want more air, so a higher flow, like 9 liters per second, then it will just be diluted. So I tried that with this burner. So I had here also a hose with a metal pipe, and I just put it into the burner. And you will see on the video what the result was. If you put a very concentrated flow of oxygen, then it was not so spectacular, because the flow was so low that it was only in the region at the tip that you saw a very bright flame. But if you put more flow, then even if the concentration was lower, but because of the higher flow, you had more spectacular effects. So why do we have to use a metal pipe? Why could it be dangerous if you just put the plastic right in the flame? That's because you see the triangle. Maybe you saw in the last video, you saw an instruction video of the firefighters where they said in which conditions fire is dangerous. Well, to have fire you need 3 things. You need fuel, and this hose is fuel. You need oxygen and you need heat. And those 3 things together, they make a fire, and also fire hazard. When you have this hose and here inside is oxygen, and you put it close to the fire, you have all the 3 things together. Then you must be very careful. So what can happen? That the fire who finds oxygen and fuel together, that will go back. And then it will splatter, and it will make very hot drops of plastic, and it will go everywhere. Maybe on your clothes it will start burning there. So that's really something to avoid. So I had a nice long tube, and then in this tube you have oxygen, you have the heat, but you don't have fuel. So that's the reason that it cannot go along this bridge. So that's a safety measure. At some point I put it in the burner, this point, and then you see here the effects. But at another point you see that I put the meshwork on it, and then I blow with the oxygen through the meshwork. And then you see here on the video, I don't know if you can see it very well, but with my eyes I saw, with my eyes, but also with these glasses, I saw that below the meshwork there was a very fascinating whirlpool and play of colors. And indeed, with this meshwork, the flame below the meshwork was becoming green. So that was very nice. I will now, during the editing work, get these colors as I saw them with my eyes. Okay, so now we are at the end of the video. I showed you my experiments. I showed also that not everything was going right, but I told you also what I want to do in any of these problems. If I'm not ready next week with these experiments, and if I cannot give really interesting results, I will just show you another thing, because as I said always, I want to stay in the 360 degrees of the home energy, about innovations. And maybe the next week I will give you a video about the retrofit of an old pellet stove. So now this video comes to an end. I would like to ask you like, subscribe and share this with your friends so that you will sustain me. And please put comments and questions here below comment field, because maybe you have an idea, maybe you have some experiments with the errors which I made, and you can say me what I can improve here. Also, if you have some interesting idea which you would like more information on and more experience and more how to do it, then put it in below in the description, and I will try to put it in the agenda for the coming videos.